Hey, YouTube, how is it going? It's been a couple days. It's been a rough couple of weeks. So, anyway, what you're seeing here is another progression, another update on this tube preamp pedal build that we're working on here. And as you can see, I have done some work and collected some parts. So we're going to talk a little bit about why it takes me so long to do this. Again, we're talking a little bit more about why it takes me so long to produce content, but to also just kind of show the progression and why I came to essentially what we're looking at right now. So this is more or less how it's going to lay out. And you can kind of see there's a lot going on in this little box right here. This little box, I believe, is roughly 5 inches by, I think it was just over 7 or something like that. No, excuse me, just under 6. It's more like 5.5. So pretty small little box. It's only about 1.3 inches deep, or 1.3 inches deep. So pretty small box for all this stuff to go on or in and have tubes sticking out of the top of it. So let's go over to do we want to do that? No. Let's talk a little bit more about the format change actually that's going on. So maybe you noticed that, maybe you didn't. There's a slight difference in the video. I think the quality of the video overall has kind of shrunk a little bit. It's not quite as good. Objectively, what I'm trying to do is make this easier for me to do. And historically, what I've done is I use my iPhone here. I would record all the video, and I would, if I had any screen, captures that I was doing, I would do that with OBS, and I would have to record the audio as well with OBS or another third-party software. Or another software. I got to the point where I could at least do the audio and the screen capture with OBS, and that was fine. But still a pain in the butt. I don't know if you've ever shot any large videos with your iPhone. You do not just take that video, shoot it, run inside, plug it into the computer, and then offload it onto your computer. No, you got to wait for Apple to sync it up to the cloud or whatever the heck it does before you can then just go in and start pulling it down onto your computer. I have come across errors when I tried. So when I first started doing this, I'd shoot like an hour-long video or whatnot, run inside, plug it into the computer, try to download it, and it would start. Sometimes it would work, sometimes it wouldn't. I had a few that came out corrupted, and it took me probably about a half a dozen times to realize that I just had to sit on it for, a few hours. Usually about an hour, hour and a half. By that point in time, Apple's happy with what they got going on. They've copied all of my metadata and all the other fun stuff out of it that they wanted. And then I would be able to download it. Well, a large file, an hour-long video with an iPhone shot at 4K is roughly 10 or 12 gigs or more. So it took a long time for it to move. I have a fairly old computer. It's not like a super-duper new one, but it would take a while to download. And then I have to move all the other stuff, the OBS recording, etc., etc. I have to move all that over and then put it into DaVinci. And I was doing all my editing with DaVinci. Great software, by the way. I do like DaVinci. If you're going to get into this kind of stuff, I would definitely check it out. Obviously, there are better products out there, but you have to spend money. OBS is pretty dang cool. I'm not going to lie. OBS does a really, really good job, but it is free, and it did let me down the other day. I was going to do a live show, I think it was last Sunday. Had it all set up, prepped, ready to go. Tested this thing like 5 or 6 times throughout the day just to make sure I had everything, prepped and ready to go. And it worked flawlessly on all of my mock streams that I did. I did a few test streams. Worked flawlessly. Go to actually do the real thing, and it gets through the countdown that I have, and then it went tits up. Like, it just said, I'm out. I'm not doing this. It started having some audio glitching and all kinds of fun stuff. So I had to stop my stream, which I think I had like 3, 4, maybe 5 people waiting in queue for. Right in there. Had to kill the stream and then start a new one. Well, I think only 2 or 3 of them came back, which is kind of a bummer. So as a small guy trying to make things really, really, have some sort of production value, because I know my hands and stuff are boring. Well, that's just the name of the game. Sometimes you win, sometimes you lose, and that one I lost big time. That was definitely an embarrassment on my part. So as much as I want to say it was OBS's fault, it was kind of mine too. Maybe I tested it one too many times and should have just left it alone, right? I don't know. So in either case, now, with the way I'm doing it now, everything's being done through OBS. So I'm recording in 4K with a new camera. So I got a new camera. It doesn't do as nice of a job, I think, as the iPhone does. So the quality of it, even though it is shot in 4K, is a little bit lower than I'd like it to be, but it works. You can see the detail. Excuse me. Sorry, I got the little burpees. I got my Dr. Pepper going here. It's not a show with me unless you've been burped on. I don't know what it is. But in any case, so yeah, I think the quality overall of my videos is going to kind of diminish just a little bit. But the hope is that I'll be able to more quickly do this stuff. Instead of spending, if I shot an hour-long video, it would take me at least 2 or 3 hours just to get it ready to download or, convert, if you will, because it would change it from the HEIC or whatever, the H.264 into the MP4 that YouTube wants. Well, now I'm able to record it directly to MP4, so it should make things a little bit easier for me to do, and hopefully I can do these a little bit more often without as much effort. So some of the mistakes are going to be a little more obvious and less edited out, I guess, because I'm not really trying to do all the editing. I shoot everything in one shot anyway. So that's why you hear me rambling on as much as I do. I think faster than I can say. And when the words come out, by that point in time, I'm already moved on 3 or 4 things away. And it just doesn't come out right. So then I have to retrack what my thought was. And then that's what you get, the ums and the ahs and the always thinking about what's next on my mind. Because I've already moved on to 3 other subjects in my mind. Anyway, let's go over to the screen. And we're going to take a look here at what kind of started this all. So here we're looking at the original schematic that we showed in the first episode. What I can tell you is that this schematic, as you see it, will work. I did confirm that the ground for each of these is linked together, so it is a common ground. So that's kind of good news. For me, that's good news because it just means I can, everything's kind of common at this point. So all these grounds here can go to the same point. It's not going to matter. But as far as the schematic itself goes, it will work if you build it like this. As far as the values go, I'm sure the values are just fine. I'm not certain if we're going to need a grid stopper on V2A. There may need to be one there. So more or less what I'm getting at is it's always caveat emptor. I say this a lot. I use that term a lot, but it's very, very true. If you're not very familiar with actually building and designing your own stuff, especially electronics, and especially one like this where there will be 250 plus volts rolling around inside of this pedal, you might want to be sure that everything's going to be correct when you put it together. So while this may be correct, none of the values here are set in stone. So don't just take what you see and run with it. Always confirm before you just take something like this and build it. And let's go to the next thing here. So what we're looking at here is the first rendition of the layout that I created. If you recall, I did show this in, I believe, the second episode where I was kind of showing how I kind of came to this, the decisions that I did. But it was based on, let's go back to here. It was based on this guy. This turret board was much, much bigger than I thought it was going to be. And the layout of it, in this orientation just wasn't going to work. And you can just already see just the turret board itself is almost as big as everything else within this pedal. So it wasn't going to work. I thought maybe I could just make it work just to build kind of the prototype and get it done. But that's not the case. So get the heck over there and stay. All right. So I have some of this laying around, which is just some more turret board material. It is obviously smaller in size than this original one here. And you can see that I basically just kind of condensed the layout a little bit to fit Oh, you can't see. Sorry. So obviously we're talking about that little thing. So I condensed everything down to this, right? So it's just a little bit smaller. You can see it kind of takes up more or less the same space. But even if I were to cut all of these unused areas out, it still just wasn't going to work the way I'd hoped. I liked the layout of this one here better than this one. It would have laid out really, really nicely, but it was still going to take up too much space. And you can kind of see again that this thing has to sit in here somewhere. And it came down to this guy here. Where these two sit in plane with each other. Let's see if I can get this lined up. So where these would sit in plane with each other, they were always going to come into contact, or the Phoenix connectors here were always going to end up like in something that was on this. Now I don't necessarily have to use these Phoenix connectors here. I could unsolder that and then just solder the wires directly into it. And I thought about doing that, but that kind of took away from the objective of this thing. I'm trying to make this thing as simple as I can. And this part is probably going to get redesigned to fit the way I want it to fit actually. So I'll probably try to find a way to condense this a little bit more. But in either case, it was never going to work no matter how I did it. So that's when we come into these guys here. And let me show you what that actually is. So these little gold things is what we're looking at. So these little turrets here are pretty freaking cool. Now what I like about them too is that they're bifurcated. Let's see if I can get it to focus on that here. There it is. You can kind of see that they've got that little cut in there. So they're bifurcated. Now the bifurcation is cool because you can just lay the wires down in there, and it does have a hole down the middle, but the only downside of that hole is you can only fit one component down there. You cannot fit multiple components down there like you can with those other turrets that I use. And that's kind of showing or proving to be an issue, at least with these little guys. So what I think I'm going to do with these is find another version that has non-bifurcated and more like just press fit style ones. These ones are like screw-on style, which is kind of cool because you can just take them out. But, you know, they're just like these little things there. And they do the job. It's pretty cool, but I'm going to try to find, these things are not cheap either, by the way. I think these things are about $5 or $6 a pop. So it'd be nice to find something that's a little bit cheaper, if I could, and has press fit turrets on there. Mainly because I don't know. I don't like these ones. I want to be able to fit multiple parts in them. These ones are a little bit of a pain in the butt to do that. Now, the only cool thing about the bifurcation is that you can twist the bifurcation to the direction you need. So when you want, you can lay the part in there. And there's going to be a few parts that obviously go off at an angle, and it would be cool if the bifurcation lined up properly. Another thing you may notice is that I flattened out see if we can get it to focus. I flattened out the tube socket. And I flattened out the tube socket to allow for more space underneath, because these things do hang down from the top down. So if you can imagine, the floor of the thing is going to be sitting here. So that just bought me a little more space. And I'm using 3/4 inch standoffs here. What's kind of cool is the way that I set them up with the little turret board, or whatever you want to call it. Actually got the tube socket down just a little bit more. The tube is still going to stick out the top of the chassis by about an inch and a 1/16 or something like that. A little bit more than I would like, but you know, that's not the end of the world. We can make it work. So another thing you'll notice about this guy here is that I've got two different standoffs. These ones here are just over, I think they were just over, or just under 3/4 of an inch or something like that. I can't remember exactly. Let me find out. Yeah, they're 3/4 of an inch. So these ones are 3/4 of an inch, and these ones are 1/2 inch. Do the math on that. I think it's like 1 3/8 or something like that, right? Is it 3/4? No, it's not 1 3/8, but 3/4 of an inch plus 1/2 inch is 1 1/4 inch, excuse me. Well, what's kind of nice is this box is 1 3/8 inch deep. So I've only got to make up 1/8 of an inch. As luck would have it, by the time you start throwing a couple washers in there, you end up eating that 1/16 of an inch on either side that you need, and it centers this thing really, really nice inside of the box. So the reason that I have it in a little Z pattern is so that way I can put it inside of the box. I'll show you what I mean. So it'll go inside of the box like that, and then these will connect to the back of this. So this is the back plate. So there'll be a couple holes in the back plate that will lock all that together, and you can just see, you can just kind of see there that these things stick up. What's nice about the way this plate works is that it is actually recessed, the inside of this plate, and you can kind of see here. So the face that actually rests on the chassis is higher up than the actual recessed portion on the inside. So that will fit in there almost as it is without any kind of fun stuff going on. There's just enough room by the time this thing goes in there that when these pots are underneath, they'll just fit underneath. Right? They'll have just a bit of air, enough air that I think we're going to be A-okay. So I will put something on the back of the pots, perhaps, maybe like a little piece of cardboard or something in here, just to protect the backside of the pots, or some Captain tape or something. I'll put something to make sure that these don't touch this in any way. But everything's going to kind of lay out really nicely. This will go in that little area there. If I can get it to stand up, that would be cool. Obviously, this guy will go like this. And you can just see how it will all fit, just fit in there, right? Yeah, there you go. So it'll all fit in there. The button will go right over in here, yada, yada, yada. You can see I've also drew some lines on this guy here. I went ahead and spent some time just kind of designing things a little bit ahead of you guys. Obviously, you would hate me if I actually took you through the journey of getting to this point here, because let me tell you, it was a job and a half, and it did not happen in an hour in real time. So you're going to be glad you didn't watch me do it. But let's kind of find how I came to this conclusion on things. Obviously, I was looking at other pedals and trying to find like where common placement of these things were. This button here was kind of in about that zone, and I have enough space over here to do the same thing if I did put a second button. These guys here, I only had one. I need to order some more apparently. So for now, we're going to have a normal jack as a stand-in for it, but this one will be the input. This one will be the output. So yeah, that'll go in there. The pots are all going to go right in here. And let's see here. And then they'll fit underneath this guy here on the bottom. So these will just rest right over the top of them. And I do like the placement of the pots in this thing. So I'm happy with that. So we'll have those four knobs right there. And of course, the only other thing that you'll see on the top here will be that. And then of course the tubes that stick out. And then what I'll use is like a couple of handles for like a drawer. I'll use those nice, stainless steel handles that I'm hoping to find like a 4-inch long one that, has about an inch and a half of depth or something like that. I'd like to get one that has at least an inch of depth. But then that'll go over there, over the top of the tubes to protect those from getting bopped. But as you can imagine, there are a lot of little things to think about when it comes to designing this, because I wanted it to fit inside of a chassis that was a standard size, and this one here is about as close to a normal sized, effects pedal, if you will, as I could get. It is a double wide, but it's not much bigger than, actually I think this one is smaller. So I have an Ernie Ball, what is it called? It's the Dark Sun. I have an Ernie Ball Dark Sun. And this is about that size. It's a little bit thinner, actually, so it's not as deep as this one, or as that one. And I think width-wise, it's within 1/8 of an inch of the width, and either dimension, it's within about 1/8 of an inch. And this one is going to have 2 tubes in it. I have a Crazy Tube Circuits Unobtainium Raw. Whatever that gray box colored one is, the newer one that they came out with. that one is just a little bit smaller than this guy here. And then I have I don't even know the name of the company that makes it, but it's the Gristle King. The Gristle King is one of those pedals that Greg Koch, I believe his name is Koch or Cooch, Greg Cooch. Cool cat, by the way. If you've never seen him, check him out if you can find him. It's Koch. There's actually an amplifier company called Koch as well. That is a Japanese brand, though, not affiliated. Totally different people. The Cooch, whatever name, from Japan, they've actually been building amplifiers for, since the 70s, I believe. So they've been around a long time, something like that. But yeah, a lot of little decisions that you have to make, and then you have to make sure that it's all going to fit inside of the space too. So that's why it takes so long to do this kind of stuff. I like to over-engineer things. I want things to be right the first time. You know how what's that saying? You know how you done it right? You done it twice. But I try not to make too many mistakes, and I really didn't want to design it using that other turret board to get it where it was and then have to spend the money all over again to actually build it the way I wanted it to. I figured I'd spend all the time and do all the R&D on the front end, front load it, and make sure that it was going to work right the first time. So that way I can do addendums to it and, dial in a little bit easier. One of those other things where you have to make a decision all the time, there's always another decision, is what knobs to use. So I really would like to use this knob here, but if you look closely, you can just kind of see that the washer sticks out further than the knob itself. So the problem is that this one is really, really small, obviously. The skirt on it isn't as deep, and I'll show you the skirt on this other one here in a moment, but the skirt on it isn't as deep, so when this thing is sticking up, this thing here isn't going to cover, it won't go all the way down to the chassis, right? It'll stick up off the chassis a little bit. So then you're also going to see the nut and the washer. I don't like that. To me, that's a little ghetto. As much as I love the feel, the alpha pots are perfect for building amplifiers and pedals with. They just have the feel, and the taper that they have is right for these kind of amps or these kind of projects. They do not work very well for guitar, unfortunately. The taper on these on their upper end, so when you're at full volume and then you go to crack it down a little bit, is not very smooth. It's like they spent all of their energy making the off to on the best that it can be. So when it comes to using lower volume levels or, something like the volume control on an amplifier, the alphas just seem to have the right taper in that low area there. So from, off to on, it's a little bit smoother, not so abrupt. Whereas CTS does really, really good when it's in the full on position and you turn it down a little bit. It's like they inverted the taper of the pot or something like that. So CTS works really good when it's all the way up, but when you go to turn it all the way down, there's like this really wide area where there's nothing. So you turn it up a little bit, it doesn't do anything, and then all of a sudden, everything's there. And it's just really abrupt, and I don't like that about CTS. So I use alphas, those PECs, those Borns, and all those other pot brands. I haven't found any that are just any better than these that feel the way that these feel. These also feel very nice. They're just smooth and right. They just feel right. I think I'm going to end up having to go with the larger knob, though. These are the ones I use for my amps anyway, so it's objectively what I would like to use. I was just hoping to get something a little more compact, I guess. But I'll probably end up using these larger pots, or these larger, things here. But let me show you what I was talking about with the skirt. So you can kind of just see, as I bring it up, you can see that little skirted area there. It's the plastic that hangs down underneath where the ferrule is for the thing, for the post. Well, what's nice about that is when you go and you stick the shaft in, it goes down over the end of the shaft a little bit. So if you have any shaft that sticks up, any threaded area, it'll help hide that, which also means that you can get this a little bit closer to the chassis, if you will. I guess I can kind of try to mimic that, but you can imagine this is like like what this one would be, sticking all the way up here because the pot is so tall. Whereas this one here can get really close to the chassis. I'm trying to mirror it at the same time, but get really close to the chassis because that skirt is there and it can get deeper onto the pot. Right? So all kinds of little decisions that you have to make when you're designing these things. Once you kind of get through all that, though, it kind of solves itself. This is a button that I had left over from some other build. I may use another one. I don't do pedals, so I don't have a ton of these laying around, but I may have another one that I can use. It's a little bit smaller, and maybe a little bit better. I like the way this one feels. It's got a nice touch to it. But in either case, I do need to order another one of these, as I had mentioned. And then just the parts in general. You got to spend the time and decide what parts you're going to get. I'm going to go with the Sozos on this one. I'm going to use the Dales, these metal films here. And the only thing that I'm not going to keep in this build here is this guy here. So that silver mica is one of the coupling caps I use. That guy there is 500 volt. So it's, double at least the voltage rating that's going to be running around in this amp and that this part is going to be, dealing with. The problem with these cheaper SM labeled silver mica caps is they're not very robust. They're not, they're more prone to failing. That's, I guess, the simplest way to put it. So putting them in a coupling cap position is kind of dangerous. Not dangerous, but when it fails, it's going to cause all kinds of issues. And it might not hurt anything, but it certainly doesn't sound good, and it's not good, right? So we're definitely going to replace that with the higher quality version. I usually use the Sozos, but the Sozos are really, really big. And I just couldn't do it. So I'm going to have to use a CDM that is the size that I want. The CDMs I think are rated for 1,000 volts or something like that. And they're just a little bit more reliable. And the CDM is the Cornell Doublier, by the way. So the Cornell Doublier brand are the better versions of these. Now, when you're using these SMs as a treble bypass cap over like a volume control or something like that, it's not as problematic there. There's not a whole lot of voltage anyway, so they're generally well under the voltage that they need to be safely operated at. And even in a coupling cap position, they're well underneath the voltage rating. But in that position there, it's already after a cap anyway, or a coupling cap, that is. So the DC element that, is you don't want to get past this guy is already gone because of that previous coupling cap. So these generally don't have a problem when they're used as a volume, like a treble bleed or treble bypass cap, if you want to call it that, when used there, because if it does fail, most all of the bad stuff is already taken care of prior to this. Now, since this is the primary coupling cap, I do need to up the quality a little bit here. But for testing purposes, this will have to do until I can get some more parts in. There's that. I decided that for this, I'm going to go with the MODs, mainly because they are the size that I really kind of need them to be. Hold on real quick. Let me go get you one of those other ones I was talking about, the Nishikons. It's down underneath this. There it is. All right. Sorry, that didn't take too long, I hope. But you can kind of see what I was talking about in terms of the size. So this one here is a 33 UF at 450 volt. So it's just a little bit bigger than this one here. So this one's a 30 UF at 500 volt. 450 is more than enough. This is, by and large, a better capacitor than this one, even though they have pretty much the same ratings. This one's rated for 105C. This one here is rated for 105C as well. What I can tell you is I know that this one's rated for like some ridiculous number of hours. Although they say some pretty ridiculous things for these. They say that these at voltage and at 105C, these things last for 20,000 hours or something like that. I know that these ones will here. Here's the funny thing. This was still a $3 or $4 cap, and it's not as good as this one here, this Nishikon. But this Nishikon was only about $1 or $2, so at least half the cost. This is a real cap, but how do you put this freaking thing in here, right? The way it's going to go, let's go back to the screen. So you can kind of see there's just no real way to get a radial cap in there other than to put it literally on the turrets in this spot here. But then I got to figure out how to get the HT to them and the ground to them as well, because the HT and the ground would be in the same spot on either side. So that's the part that was kind of a bummer. And as you saw, it's nearly the same size as the other one. It's about 2/3 the size. It's the same width, I guess you say diameter in this case. About the same diameter, but it's about 2/3 the length. So it's 2/3 the size. So where would I put it, and where it would make sense? I suppose I could put it on the ends and point them in, but then this large thing is going to be sitting there floating in midair. So imagine this. We're going to go back to my hands again. So if you can imagine this guy here just kind of floating in midair. Now the leads on this are a little bit more substantial than these, but there's just no way to get this thing to fit and be reliable. And the sizing is off a little bit too, but if I couldn't put it like that, although maybe I could, it might work that way where it goes, literally shoots into the top like that or something like that. Let's see if I can do this without anything falling. You know what I mean? Like I could do something kind of like that, but I didn't want to bend these leads out to be similar in regards to this. And it just made no sense. So I decided we're not going to go with the Nishikons this time. We're going to go with the MODs. And I don't choose parts because they're cheaper. I generally look for the diminishing returns. These ones are actually cheaper than the ones I normally would use, which would be like the F&Ts or something like that. But the F&T does not make one of this size, so 30 UF, that is as good as this one, at least in terms of the spec. And you just all kinds of so this guy will sit in here like so. If I could get it to line up, there it goes. So that'll just sit in there kind of like that. It'll be tucked away all nice and pretty like, and it won't take up too much space. So there's a lot of planning that goes ahead on the front end on these things. So that's what takes so long, is trying to plan all this stuff out. So let's talk a little bit about I guess what they call parametric versus linear editing. So let's go back to the screen over here. So the software I use to make this is more or less a parametric editor. So if you do one thing, you don't necessarily have to undo the last thing that you did. So in a linear form of editing, let's say you put this part right here and then you put these turrets at this distance. Well, let's say you wanted to change where this particular turret was at. If it were linear, you would have to undo everything you did up to that point before you could adjust where it went, and then you'd have to add everything back in again. Where with parametric editing, you can put this part there, connect everything you need to it, and then if you decide later you need to move it, well, this will allow you to move it, and it will shift everything else with it. It will update everything else to follow along as needed with it. So that is the challenge. Is it really already 6 o'clock? Wow. So the challenge is when you're doing this kind of stuff, both on, paper or in a software program, and by hand in real world in front of you, you want to try to do things in such a way where once you do one action, it doesn't screw you or lock you into being, stuffed with that action, I guess. So that's what's taken me so long with this guy here. We're working on like 3 weeks now of videos with it. And it's literally me spending the time like, okay, how am I going to put this in here? How's it going to fit? Okay, well, if I don't like that first turret board I got, how will the second turret board work? Second turret board doesn't do what I want, so let's find these. And then I, spent half the day dinking around with these to see how I can make these work. And then I came up with this decision here where I use 3 of them. I bought 4. I only used 3, and then I ended up taking half the little turret things out, the little screw-in turret lugs, right? So all those little things, also I could come up to a point here where this guy will go together more or less like this, and where is it? Look at that one. And we'll all fit in here. All these things I do for you guys. And try to create, I guess, if you will, somewhat of a lesson plan for it. I'm not like your teacher or anything. That's not what I mean necessarily, but I try to make this channel like a learning channel. So as I drag you along with this, I'm trying to show you all the things and problems that you'll run into. Now, if you're already a guy that builds these things for a living, you're going to look at me and you're going to go, Luke, shut the hell up. You're a goofball, and just leave us alone. But for those of you who are not as initiated in regard to this kind of stuff here, you're probably wondering how the hell you come to this solution. I'm hoping that my path and my journey with you shows you those things and explains in such a way that it's clear why you do this, why you do that, and how to safely kind of pull it all together. So in the next video, I'm not going to do it in this one. In the next video, we're actually going to start drilling this thing out and putting parts in here. I don't know how many more videos we're going to have of this guy. I'm hoping to make it it would be nice to do it in a 4-part series, but I think it's going to more or less end up being a 5-part. I think what we'll end up having to do is, in the next episode, we'll get all the holes drilled, or I'll have all the holes drilled already, because you don't need to hear my machine just running off in the background. You're just watching me put holes in metal, right? But I'll drill all the holes in this thing, and you'll just watch me stuff all the parts in there, and then we'll start perhaps soldering all the things in there. The soldering side of things, I think you can kind of get a grasp on. It might actually be fun to watch me. I figure that one I might do as a live video, mainly because it will be a little bit longer, and I don't see people being that interested in watching me build this in real time. If you've gotten this far in this video and you actually want to watch me do this, complete, build this thing, solder it, the whole 9, let me know if you're into that. I will have a video obviously that shows building it, but if you want to watch it being done in real time, let me know. Otherwise, I don't know. I don't think we're going to actually do any sound tests in that particular video, because I'll still have to do some testing to make sure that I'm not going to do anything stupid like blow up. I don't want things to blow up, so more or less what we'll do the build, we'll get it all complete, everything's looking good, and then we'll save another video to actually do the demo of it. Maybe even show some of the modifying, because I'm almost positive, if we're going to go back over to here, almost positive that some of these things are going to require some different values. The areas that I have question marks is whether or not I'm going to need a grid stop. That is one area of question mark. I may shoot for more gain over here, so I may use a larger value there. Don't know yet. I may need to change out these 2 pots right here. I'm pretty sure 100K will work, but I don't know that 100K will work here. What I can tell you is that this is going to suck a lot of gain away, or a lot of volume away, and it will do so at the cost of darkening up the pedal a little bit, and it might be too dark. So I may need to use a 500K or a 250K pot there. I don't know yet. That's what we need to find out. I may need to put another parallel resistor in here. Maybe 100K works great, but then I need to dump a lot more voltage, so maybe I need to put a 10K as just kind of like a something. We don't know yet. I have to figure all that stuff out. Most everything else in this amp is pretty much, I think, kind of set in stone. I know that it will work the way that it is. Voltage wise, I'm not certain that R11 and R12 are going to be the values that I have chosen. Right now I'm shooting to use about 10Ks or 10K resistors in those spots there, but I do not know for sure yet what value it will be. I have to kind of figure that out. I know where I'm shooting for, but I don't know if that's what it's going to be. And then we still got to do some other testing. Again, I have not actually turned this guy on yet, so I don't know if the 6.3 volts is going to work the way I expect it to for the heaters. The hope is that it should. It says it's 6.3 volts, so there's no reason why it shouldn't, but I got to do some testing because it has a ground and 6.3 volts. Well, the ground is shared amongst the two, but I'm using a ground and a hot for the heaters. So I don't want any kind of heater noise getting into the circuit. So I need to find out for certain that I can go directly to the heaters on these tube sockets and not worry about how it's going to affect the ground side of things. Because if I do get a short from, say, cathode to ground in this guy, it could cause all kinds of hell. So I don't know if I need to isolate the heater circuit yet. That is the high current circuit in this box right now. I think I went over it in one of my other videos about how these things kind of work, where it seems almost impossible that you can stuff 9 volts in here and get 200 plus volts out this other end over here and feed, 2, possibly 3 tubes with enough current to manage the heaters and, deal with the current flow of the energy through the tube itself. In this case here with 2 tubes that pull 330 milliamps a piece, we're talking, or 300 milliamps a piece, excuse me. We're talking 600 milliamps, so we're just over half an amp just in heaters in this guy. And then we still have the plates. Now the plates pull right about 1 milliamp each, so not a whole hell of a lot. It's pretty insignificant. But if you're only using a 500 milliamp 9 volt adapter, how on earth can this power all of that when you know that you've got at least 600, let's just say 610 milliamps worth of current draw on the other side? Well, you do have to remind yourself that this is exchanging voltage for one thing and current for the other. So we have 9 volts going in. We only need 6 volts to power the heaters. So what we're doing is we're converting some of the current available here into a lower voltage on the other end. Well, I should say we're taking the excess voltage that we have going in and converting it into a lower voltage out, which adds current ability to the circuit. Because this thing is pretty efficient, really. It's actually very efficient. This is a switch mode power supply, which I think most of them are right around the 90 percentile, efficiency area. So if you got 500 milliamps coming in, you've pretty much got 400 and something plus milliamps of availability coming out, right? 450 or something like that coming out of actual usable current. Well, that's how it works. It takes a high voltage, converts it to a low voltage, and in doing so, it amplifies the amount of current ability that the source had. Conversely, on the other side, where you're only pulling a couple milliamps, which is nothing, like the power supply can manage that all day, well, it does so by exchanging the current that's here for voltage on the other side. So that's how it does that. And that's why you're able to power something like this here with a little dongle like this. And it's only about 1.5 inches by 1.5 inches roughly with 9 volts. That's all. So I want to thank you for sticking with me as long as you have. Do let me know what you think about watching me do a build of this in real time. I've been a little bit more boring lately. I apologize. The other show I did the other day, as I mentioned, I was really upset at the fact that the intro got biffed and I had to restart the stream. That really took the wind out of my sails on that particular episode. Some people said they didn't really notice, and I try to make it not so, I don't know, I beat myself up on that one. In other news, I did have a friend pass away the other day. Tragically, I would say. Quite the least, to say the least. So that's kind of wearing on me at the moment. And I'm kind of using this video here as a way to keep my mind off of that and just keep trudging forward. We'll just leave it at that. So in either case, I want to thank you so very much. Take care. We'll see you in the next one. Bye-bye.